Hello, I'm Terry Stringer with Hydrology Studio. Thanks for joining me. Today I'm going to be providing an introduction to Channel Studio. And if you're new to Channel Studio, here are some important points I would like to make. One, it was designed specifically to be an easy-to-use alternative to public domain programs such as HEC-RAS and WISPRO. It's not a data wrapper or some user interface on top of HEC-RAS. You don't need AutoCAD, you don't need HEC-RAS or any other software to run Channel Studio. It's completely standalone. It uses well-known methodologies, including those employed by HEC-RAS, and you can model most any open channel system, which can include natural or man-made channels, bridges, culverts, and inline weirs. You can also add a background map to draw against from either an image file, a DXF, or land XML files. You can also import a tin surface from which you can cut cross sections. So as you're about to see, the user interface was designed to minimize inputs, eliminate messy dialog boxes, and put everything right in front of you. So let's get started. When you first open Channel Studio, it'll default to the model tab, which is a large white canvas, as we call it, and you'll see some dimension lines at the bottom. In this case, we see a 1,000 feet dimension all the way in the X direction, and the Y is 575, which is based on the size of your window and your screen resolution. But anyway, today we're going to be modeling a section of reach which is 1,000 feet long, and it's going to have about 11 cross sections in it. So I'm going to draw the reach, but before I do that, I want to make sure I have enough space in my canvas here to draw that. And right now, right at 1,000 might be a little short. So I'm going to take my mouse wheel and I'm going to zoom out to about near 1,700 feet there. That gives me plenty of room. So to draw my reach, I go to the reach button on the side toolbar here and click that. And then I move my crosshair to the most downstream section of my reach. I work from the downstream going up. And the reason that we go downstream to up is because that's how water surface profiles are calculated. They start at the down and they work their way up. So that's how Channel Studio works. And I'm going to just drag my mouse in this case in an easterly direction. I'm holding my shift key, and that will make sure that it just stays perfectly horizontal. And I'm going to draw this out to where the length is a little bit over 1,000 feet. I'm going to put it, say, at 1,100 feet. That gives me plenty of room. And just release my mouse and click the OK button over here, and you'll see a reach. And if I click on the extend, zoom to extents, then it will center everything on the window. And that's it. And if I click on this, it will highlight it, and over here you will see on this reaches tab the coordinates for it. And you can actually enter your own coordinates for a reach if you want to just draw it in that way. You don't have to physically draw it, you can just enter coordinate points. If you're like me, if you're a neat Nick, I'm going to clean these up. I'm going to make the easting at 0 and the northing I'm going to put at 500. And the other upstream side, I'm going to put that at, 1,050 and 500 for the northing, and hit apply. And that's going to just give me some nice round numbers. So I just click the OK button up here and zoom to extents, and we're ready to go. Our reach is done. So now our next step is to add cross sections. And you do that simply by clicking on this cross section button here and moving your mouse down near the reach. Now, you don't have to draw these are automatically drawn. All you have to do is move your mouse anywhere near the reach, and the software will place a section on that reach. So I'm going to start the first one at station 0, and you'll see at the lower part of your screen here in the status bar, the station where my mouse is currently. So I'm going to just go to the first part at station 0, and I'm going to click my mouse, and that adds the first section. And then I'm going to do these every 100 feet because it's a fairly uniform channel. So just to make things easier today for us, we're just going to do these every 100 feet. So I'll just move my mouse to where I get to these even 100-foot stations and just click. and it will add the sections for me. So there's section 6, 7, 8, 9, section 10, and finally section 11. When I'm done, I can actually go back and insert some if I missed one or not. And you can even go back later on and insert sections that way. But when you're done, either hit the escape key or click on this OK button up here. And that's it for adding our cross sections. Our next step now is to add data to these sections, and we just do that by clicking on this cross sections tab here and coming over to the input box and clicking on sections. And we will start adding data to these cross sections, starting at the downstream and going up. There is no real particular order you need to go in, but it always works out best if you just start at the bottom and work up. So I'm going to select section 1 over here in this list, and then I'm going to go over here and start entering in data for it. The section number 1, the river station, is at 0. That's already been set, so you don't have to change that. The name, you can enter in any name for these sections if you want. I'm going to skip that today in the interest of time. And so the reach length for this section, there will be 0 because it's at the very bottom part. There is no distance between it and a downstream because this is the most downstream section. So we skip that for section 1. In section type, you can either choose a trapezoidal like what you see here on the screen now, or you can choose a user-defined, which is what we're going to be doing. And user-defined means you enter in station elevation points, starting as looking upstream, starting from the left, working towards the right. So to do that, we click Define over here, and that opens up a dialog box where we can enter in station elevation points. There's several different ways that you can enter these in. You can directly type them in. You have to start at station 0, or you can copy from a clipboard if you have it pasted or have copied it from another source like even Excel or even a Word document, which I have done just to keep things moving in this video rather than type them in. So I can right click on that and hit paste data to grid, and those are my points. I click OK, and there's my section, and that's section number 1. So now that we have those the channel section points in, now it's going to be looking for the Manning's end values, and we will be dividing these sections into channel, left over bank, right over bank. So we're going to go ahead and plug in some end values for that. The left will be 0.05. The channel section is going to be 0.03. And the right over bank will match the left. And so it already defaults to that. Now we put in bank stations. This indicates vertically on their section where the channel begins and ends. And these points need to correspond with one of these data points. So if you ever need to put in a change in end values, you need to make sure in the field you get a point there or enter one in anyway. So anyway, the leftover bank is going to be at station 55, and the right is going to be at 75. And you'll see these vertical green dotted lines that indicates where one begins and one ends. You can also use these indicators up here and put them in graphically. I'll show you that in a few minutes. The next input are contraction expansion coefficients. We're going to leave those at the default. The next is the tailwater. This is the starting tailwater elevation that's required anytime that you do water surface profiles. Of course, you need to start with something. You have a choice of either choosing normal depth, critical depth, or known elevations. And in this case, we're going to go ahead and enter in known elevations. And those happen to be 90 for the first profile. We can do up to 3 profiles. The next one is 91, and the final one we'll start at elevation 98. So I hit apply for that, and section 1 is done. Next thing I need to do is just go to section 2 and repeat. And rather than go in and enter in section data, we're going to show you some other features of the software where I don't have to do that. River Station 100, which means if you go back to the model, 2 is 100 feet away from 1. And so that's why you see 100 here. It automatically entered it in. It entered the reach lengths at 100. Now, if your channel is meandering a little bit between these, you can enter in a longer channel reach if you want. And if it's on a curve, you can do left over bank greater than the right, and so on. You can override these. It won't have any effect on the placement of the section along the reach. So those are already set at 100, and we're going to leave them there. So the next part is, again, we need to choose our section type. But what we're going to do now is I can go to the list over here, right-click on it, and copy previous section geometry. So I'm going to do that, and it's going to copy everything from section number 1. And of course, this is going to be on a slope, and so this section goes up by 0.25 feet from the downstream one. So I can put in 0.25 here and hit the apply button, and it's going to raise this channel up by 0.25 feet, as you can see in this gray dotted line. And so if I'm happy with that, and all the other data here had already transferred over, the end values, the bank stations, so I can just click apply. And that's section 2, and it's done. I'm going to do the same thing for section 3, right click, copy previous geometry. This one also goes up by 0.25 feet, so I'm going to hit apply to that and hit apply down here, and I'm done with section 3. Now we go to section 4. And if you're, let me go ahead and copy this first, copy previous section geometry, and there is a copy of 3. Now, if you have acquired your data, say from HEC-RAS, or your surveyors went out and they goofed and they got it from as looking downstream rather than up, then all your coordinates are going to be backwards. So rather than you having to go through and revise all those as if they're looking upstream, you don't have to do that. There's a feature in the software that will allow you to rotate a section. So you would go ahead and enter it in as if you're looking downstream, and then hit this little rotate button right here, and it rotates the section. I'll do it again. Here's the original, and then here's after it's been rotated. And that's all you need to do. And so I'm going to go ahead and keep that rotated for now. I'll show you why later. It also goes up by 0.25 feet in slope, so I'm going to just apply that elevation adjustment and hit apply. Section 5 is going to be, again, we're going to copy 4, and it goes up by a distance of 0.75 feet. Has a little bit steeper slope, so I hit apply there, and you can see the dotted line as it adjusts, and I'm going to hit apply, and it will set it up to that elevation. Everything else stays the same. Section 6 is going to be a copy of section 5. So we'll go to 6 and we'll copy previous. This one goes up by a distance of 1 foot. So the slope is actually getting steeper as we're moving upstream. Apply to that, and now we'll go to section 7. And again, it is also a copy of 6, and it goes up by 1.25. Should make things interesting when we do the profile. And I'm going to hit apply there and apply over here, and section 7 is done. So now we're going to go to section 8, and this time it's not going to be an exact copy. This is a land development project where we're doing a little bit of changing of we're going to clean up the channel section up near our development. So we're going to put in a different section. So in this case, I'm going to go to my inputs over here, and I'm going to choose user define, hit the define button, and put in my user points. Now, if you happen to have, and this is common, you can put these sections in the raw survey data. If it's in a spreadsheet, you can come in here and copy that right out of Excel. I'm going to copy that, and I can just go right to here, and I can paste the data to the grid, and there it is. And as you can see, this is a cleaner version of the previous section. So those are the points for section 8, and the leftover bank ends are going to be the same. It defaults to the one that was previous, so I don't have to retype those in. Leftover bank, I'm going to do those graphically. Just click this over here, and it will move that dotted line starting from here to the next one to the next, and you can move all the way across. And here is the right over bank line. So those are set, and all I have to do now is hit apply, and section 8 is done. So now we'll go to section 9, and 9 is going to also be a copy of 8. So we're going to copy previous, and 9 goes up by 0.25 feet, so 0.25. And for the adjustment, and I'm going to hit apply there, and everything else over here is copied over. I'm going to hit apply. And 10, we're almost done. 10 is also going to be a copy of 9, and it flattens out, so we don't have to do any adjustments whatsoever. 11 is also going to be a copy of 10. So that's it. We're done entering in our cross sections, or at least our cross section data. The next thing we need to do is to enter in the flows. So we just need to add some water to these sections, and so we're going to click on this flows tab over here, and you'll see this table that goes section by section, and I can enter in flow rates for up to 3 different profiles, and they can vary from section to section. Our first profile will be 300 CFS, so I'm going to type in 300, hit my tab key, and I'm just going to keep doing that. It's just going to go ahead and keep entering that in for me, which makes the inputs easy. The next one's going to be 450 cubic feet per second, and I'll add those in for the second profile. And the third one, it's going to be quite a bit more. This is going to be 2,500 CFS. So I plug all those in, hit apply, and so all of our flow rates are now entered in. Now, if you're probably wondering, can I label these profiles as 5-year, 10-year, 100, or pre-development, or existing versus proposed, and so on? Yes, you can. You go up here to the project settings, and you can, and I've already put these in, but under the flow profile 1 ID, you can put in all these different, any label that you want, and it will be shown then on all of your reports. So now that we have our reach in, we have our sections, section data is in, now let's go to the profile. And now you can see this heavy green line at the bottom. The top of that green is the invert of our channels. And you can select each of these just by clicking on the number, and you can select these, and you can then see the corresponding inputs for it. So we're ready at this point now to calculate the profile. So we go over here to the Compute tab, and we can select which profile we want to calculate. We can choose friction loss options, and if you see here, it's a pretty steep slope going up, and we're probably going to have a mixed flow regime. In fact, I know we will because I've already gone through this. The average friction loss option is more suitable for something like this. 9 times out of 10, though, the average conveyance will give you the is the best overall choice. And calculation options, I do want to have it compute supercritical because we will be having some critical depth flows in here. The auto-effective, ineffective areas only won't apply in this case. When you're doing bridges, culverts, and so on, then it will. So we're just going to leave that in the default setting. So all we have to do now is just click the Run button, and you will see an instant profile. And this is the profile for 300 CFS. As you can see, as we go upstream, the slope gets steeper, and looks like we have ourselves a mild hydraulic jump, and then it goes back up here to where the slope of the channel flattens out, and we start to approach a closer profile to normal depth. Up here you have options. You can either not show the section lines or show them. You can show the overbank line if you want. You can show the energy grade line. And when you have critical depth like this, I think Y sub C, that's the critical depth. That will show you where critical depth is for each section. I think that's a good idea to have whenever you're looking at a profile like this. You can also choose to which range of sections that you look at. I can click on all off, and then we can just start to select our range if we wanted to focus more on, say, the hydraulic jump or whatever. You can do that. But normally all is a pretty good choice. So there's profile 1. Let's do profile 2 real quick and hit run, and you'll see just more of the same, just a little bit deeper flow. Now let's go to profile 3, hit run, and you'll see quite a bit more. In fact, this jump here gets to be a little more ferocious, and you can now start to see more of a traditional energy loss that you normally would see with a jump like that. So anyway, that gives us our profile, and if you go back to sections, you can see the sections are now filled with water and how high up they go. Back to profile, and then let's go to the plan view. Here's the plan, and this shows us in plan view a geo-referenced water surface. And the green here is the extents of the channel sections. This center line here is the center of your reach. And the other lines are the overbanks. And of course the water surface is the blue. I can turn off the channel, I can turn off the section numbers and just have the water surface. I can also export this to a DXF, a tin surface, an image file, or even to a RAS GIS file if you want to take it all in there and do some further three-dimensional processing or viewing, if you will. A lot of times just exporting this to a DXF is pretty nice. You can just then go back to your CAD program and overlay it. That works out pretty well. And so now we can go to the three-dimensional view, and this is just a real basic 3D rendering of your model, and you've got these perspective dimensions that you can adjust, and I'm going to go up with the Y so I can see the back side of the channel. And you can use the X's if you want to move it sideways a little bit. You can click on this section option here, and you can to show where the sections are. You can show where the overbanks are, is that dotted line that you see running through here. You can turn off the water surface, and you can also turn off the color if you would prefer to see more of a wireframe type view of that. So, and you can also, like in the other sections, or in the profile, you can also select a range of cross sections to view. So next, when you're done, you just go to the reports, and this numerical report is already pre-formatted, all set up. It gives you pretty much everything you ever wanted to know. Flow rates, it summarizes to a summary: channel, left overbank, right overbank, and you will see Qs, inverts, water surface elevation, energy grade line, the top width, even the shear if you're doing, if you're interested in the channel erosion. And then the individual channel left and right overbank sections also give you what the flow is going through there, its velocity, end values, and so on. You can reverse the order of them by this if you'd rather print them out from the upstream going down. And you can also export this report to a file if you want, but we won't do that today. But you can also get it, of course, a printed copy, which is what we'll come to next, is that to print reports, you go to the Home tab and just click Print, and you can, here's a preview of this tabulation. You can print that out. The kind of way the reports work is that if whatever you're viewing is what will be printed. So if I print this, we're viewing the 3D, that was what will be coming out on your report. Profile, I can print that. Notice that you also have options of printing it at 8.5 by 11 or 11 by 17. So whatever you're looking at, and as far as the cross sections go, you can either print all of them or a selected one. If you did all, it's going to give you all the cross sections, and one by one it'll print all those out. So that's really nice to have in your report. So that pretty much wraps that up. There are a couple of things that also I wanted to mention. If you've already noticed on the plan view, we drew in a straight reach. And so if I go to the plan, why is this offset? And you can really see it in the 3D. Why is it curving around and coming back? Well, the reason for that is when you place cross sections, the software is going to center your cross section data over the reach. So if I go here to sections, we have 110 feet wide. So the middle part of that is at 55. It's at 55 where this is placing it over the reach. And you can see where the center line of that is by clicking on CL over here, and that shows you where the center line is. If you want to center this up with your reach, you just simply drag and move this over, say, to the middle part. And that's all you have to do. Go to the next section, you can do the same. Section 3. And so what that does is it kind of makes up for if your surveyors started out at different places whenever they got the cross section. So this takes care of that without having to do any other kind of work. So if you go back to the plan, you'll see that these sections 1, 2, and 3 are now centered. And if I hit run, you'll see that it's centered along the reach. So I can do this with every one, and it'll center it all up if you want. Also, on your profile or any of these reports, you see a results tab over here. And this is section specific, and you can just go to each cross section and you can see all the individual conveyance, the alpha, energy grade line slope, shear, and things like that. And if you keep going through, you'll see this, where the total conveyance, you don't want your section going from one to the next exceeding a conveyance of 30%. Now, when you're in the supercritical flow profile, that's not really anything to worry about. It's just that when you get back into the subcritical flows, you don't want that conveyance to exceed 30% going from one section to the next. And you can see here 16%, and we go to 11, it was 11%. Going from 8 to 9, it was 44%. So what that's telling me that is I need to insert a section between 8 and 9 so that I can don't exceed that 30% rule. But again, 8 is at critical depth, so it's not that big of a deal. But just to show you how you can insert a section, I can go back up here to sections and add one between 8 and 9, just like that. Go back to my profile, go back to my sections, and section 9 is empty. So what I can do is and if I don't have the geometric data for that, no problem. I right-click this and I can interpolate. What that's going to do is going to give you an offspring between 8 and 10. It's going to basically interpolate everything between 8 and 10. Even if these sections weren't of the same shape, it will still interpolate and give you a mix between the two. So that's a pretty neat feature. Then you can go back over here to flows. Of course, you need to be sure that we enter in flows for that newly inserted section. And hit apply, go back to profile, and there it is. And I can hit run. And then I can see my results. And now going from 9 to 10, it's only 6%. And of course, going from 8 to 9, it's 36%, which isn't bad in this case. And you'll see here where it really didn't have that much of an effect on the flow profile. But anyway, I just did want to demonstrate that to you, that you want to make sure the conveyance doesn't exceed 30% going from one section to the next. You can always insert more to satisfy that requirement. That wraps it up for this tutorial. I would encourage you to go to the help section of the software. Just click on help and go to the reading room and view these articles. There's two of them here, Water Surface Profiles for Open Channels Parts 1 and 2. These are very useful for advancing your open channel modeling skills. These are very popular articles. It takes you through how water surface profiles are, how they're calculated, and some of the fundamentals that you need to know, and how to interpret results when you do get it. And the section or the part 2 takes you through dealing with real open channels and how to where and how to place your cross section. So I do encourage you to go through those, read them, and that along with this tutorial should put you in pretty good shape. Thanks again for joining, and thanks for choosing Hydrology Studio.